All right, let's pull back the curtain on one of the most important yet invisible pieces of technology that makes the internet work. It's the unsung hero of every network you've ever used, and its name is DHCPv4.
Seriously? Have you ever walked into a coffee shop, opened your laptop, and just connected? You don't have to fiddle with settings or type in a bunch of weird numbers. It just works. Well, that's not magic. That's DHCP, and we're going to break down exactly how it pulls that off.
To really get why DHCP is so amazing, we have to look at the world before it existed. Because trust me, getting a device online used to be a real pain.
Just imagine this nightmare. For every single device, your computer, your phone, every printer, you had to manually type in its IP address, its subnet mask, all of it. And you'd better have kept a perfect spreadsheet, because if you accidentally gave two devices the same address, bam, neither of them would work right. It was slow, it was full of typos, and it was a total mess to manage. DHCP completely automated that whole disaster.
So what exactly is it? Think of DHCPv4 as the automatic receptionist for a network. When your new device shows up, DHCP is the first one to greet it. It hands over a welcome packet with everything it needs to start talking to everyone else. A unique IP address, directions to the internet gateway, and the address for the DNS server so you can actually use website names instead of numbers. So how does our friendly receptionist do its job so fast? It all comes down to a super quick 4-step conversation. And lucky for us, there's a really easy way to remember it. The acronym DORA.
DORA. That stands for Discover, Offer, Request, and Acknowledgement. It's really just a polite negotiation. Your device says, I need an address, the server offers one, your device says, I'll take it, and the server says, it's all yours. This little dance happens every single time you connect to a network.
So it all starts when your device first joins the network. At this point, it doesn't have an IP address, so it can't send a message to anyone specific. So what does it do? It shouts. It sends out a broadcast message to absolutely everyone on the local network, basically yelling, hey, is there a DHCP server around here? I need some help.
Okay, so any DHCP server on the network can hear that shout and reply with an offer, saying, hey, how about this IP address? Now your device will probably just take the first offer it gets. And here comes the really clever part, the request. Your device shouts again, it broadcasts another message saying, awesome, I'd like to formally request the IP address from that server over there. This is super efficient because it also lets any other servers who made an offer know, hey, thanks, but no thanks, so they can put their IPs back in the pool. Finally, the chosen server sends one last message, the acknowledgement, which basically seals the deal and makes it official.
Now, here's the thing. That IP address isn't yours to keep forever. DHCP is smart. It works on a lease system, which is absolutely critical for managing the limited pool of IPv4 addresses we have. You can think of it like renting an apartment instead of buying a house. Your device gets to use the IP address for a specific amount of time. That way, if your phone leaves the Wi-Fi network and its lease expires, that address can be cleaned up and given to the next person who walks in. This constant recycling is what keeps everything running.
And your device is pretty proactive. It doesn't just wait around for the lease to expire. When it's halfway through the lease time, what we call T1, it'll quietly send a message to the original server asking, hey, can I renew my lease? If it doesn't hear back, it starts to get a little anxious. Once it hits the 87.5% mark, or T2, it starts broadcasting its request to any server that's listening. The whole system is designed to keep you online without any interruptions.
Now, you might be picturing a big, dedicated DHCP server, but a lot of the time, especially in smaller networks, it's actually the router that's doing all the work. Let's look at the 3 main DHCP hats a router can wear. First up, a router can just be the DHCP server. This is super common in small offices. A network admin just follows a simple recipe. First, they'll set aside, or exclude, a few IP addresses for things like servers that need a permanent address. Then, they create the pool of available addresses, tell it the network range, and finally, tell it what gateway and DNS info to hand out. Done. And how do you check if it's actually working? There's a simple command that gives you a live look at every single lease the router has handed out. You can see which device has which IP and exactly when that lease is set to expire. For troubleshooting, this is an absolute lifesaver. Okay, but what if you have a big company and the DHCP server is in a totally different part of the building, on a different network? Remember how those first Discover messages are broadcasts? Well, routers, by default, block broadcasts. They don't let them cross from one network to another. The solution is to turn the router into a relay agent. You use one simple command, IP helper address, and it tells the router, hey, if you see one of those DHCP shouts, grab it and forward it directly to the real server for me. Now, here is a great bit of networking trivia for you. That IP helper address command, what if I told you it doesn't just forward DHCP? By default, it forwards requests for 8 different services. That's right. Most people think it's just for DHCP, but that one little command also forwards broadcasts for network time, DNS, TFTP, and a bunch of older services. It's way more powerful than it looks. And that brings us to the third and final role, which is one you're probably using right now. Your home router is also a DHCP client. Think about it. The port that connects to your internet provider needs a public IP address. You didn't type that in. Your router automatically runs through that same DORA process to ask your ISP server for its public address so you can get online. So from now on, when you connect to a network and everything just works instantly, you'll know exactly what's happening. It's not magic at all. It's this beautiful, methodical conversation that keeps our digital world humming.
So why does any of this matter to you? Well, for one, you now understand the fundamental process that starts almost every internet connection. And that's incredibly powerful because it's step one in troubleshooting. If you can't get online, the very first question you should ask is, did my device even get an IP address? If you're thinking about a career in IT, this isn't just nice to know, this is day one essential stuff.
So I'll leave you with a question to chew on. Now that you know about leases, why would a network admin set a really short lease time, say just 1 hour, for a busy public Wi-Fi hotspot, but a really long one, like a full week, for a corporate office where the same people work every day? The answer to that gets right to the heart of good network design.